How to simplify equations with exponents that has fractions. So let's look at the first problem. If we have 1 over 5 multiplied by 25 to the power of x equal 5. So there's a lot of ways to simplify. But in this case, we can just get rid of this coefficient of whatever number that has an exponent of x. So how can we get rid of 1 over 5? We can get rid of 1 over 5 by multiplying both sides by 5. So remember, if you say 5 multiplied by 1 over 5 is going to cancel out, and then on the left hand side, you are just going to be left with 25 to the power of x. And then at the right hand side here, you have to multiply them out. So 5 multiplied by 5 is just going to be 25. And then we have achieved our goal to have the same basis. So if we have the same basis, we just drop the basis and we equate the exponent. So x is going to be equivalent to 1. So now if you look at the second problem, on the second problem we have x to the power of 3 equal 1 over 9. So what we want to do is that we want to make our bases to be the same. So this 9 here can be written as a base of 3. So we have what now? 3 to the power of x, and then is equals to 1 over 9 can be written as 3 to the power of 2. Remember, if you don't know how to do this, you can use your calculator to do that. And therefore, if now this is on the denominator of the fraction, if we get it up here, what is going to happen is that the exponent would change the sign. That is an inverse. So we're just going to have 3 to the power of x, and then this, when we take it up here, it's just going to be 3 to the power of negative 2. And now we have what? We have the same basis. We can now do what? Drop the basis and equate the exponent. So x is just going to be equal negative 2. So if we move on to the third problem, on the third problem we are having 1 over 2 all to the power of x equal 4. So now we can see now, okay, this 4 can be written as a base of 2, but now this half here can also be what? Written as a base of 2, because the exponent here is 1. So if we change it to move it up, so what is going to happen is just going to be 2 to the power of negative 1. It just changes the sign. And then all to the power of x, and therefore this 4 is the same thing as 2 to the power of 2. So now when we simplify here, we're just going to say negative 1 multiplied by x, that's going to be 2 to the power of negative x. And therefore it is equal to 2 to the power of 2. So because we have the same basis equated, we are going to drop the basis and equate the exponent. So this is going to be negative x equal 2. So now we can divide both sides by negative 1, and therefore our x will be negative 2. So that is how we'll do the third problem. So now if we move on to the fourth problem, on the fourth problem we have now 1 over 81 all to the power of negative x. And then we also have what? 1 to the power of 3 all to the power of 8. So now what we can do now, we can just make the bases to be the same. So this one here is just not with the base of a prime number. So we can just write that as a base of the prime number. So we just put that in our calculator, and then we get 1 over 3 to the power of 4 all to the power of negative x. And on this side here, we're just still having 1 over 3 to the power of 8. So at this step here, we can just move our bases up. Okay, so what is going to happen is that we are going to have what? Okay, 3 to the power of negative 4, because now when this thing comes from the denominator goes up, it changes the sign of the exponent, and then this is raised to the power of negative x. The very same thing will happen here. Remember, the exponent is 1 there, so when it goes up, it's going to be 3 to the power of negative 1 all to the power of 8. So now we can just simplify and remove the bracket. So the exponents will multiply out. So we are going to have 3, and then negative 4 multiplied by negative x, that's going to be 4x. And then now negative 1 multiplied by 8, that's going to be what? That's going to be negative 8. So we are equating what? The same basis. So we drop the basis and we equate the exponents. So what we will have here is just going to be 4x is equal negative 8. So we can divide both sides by 4. And therefore, the value of x is just going to be negative 8 divided by 4, that's negative 2. So that is how we'll do the fourth one. So if you look at the last one here, what we have is 2 over 3 all to the power of x is equal 9 over 4. So now in this case here, inside the bracket, this base here is just like that. There's nothing we can do. So we can just write it as it is. We have what? We have 2 over 3 all to the power of x. So on this side here, we can just write our numbers as basis of what? Of prime numbers. So this 9 here can be written as 3 to the power of 2. And then the 4 can be written as what? As 2 to the power of 2. So now remember, if you have the same exponents, you can just take it out as your power of exponents. So let me just show you what I mean. So we have 2 over 3 to the power of x. So this thing can be written as what? As 3 over 2 all to the power of positive 2, because now this exponent here will multiply with the exponent of everything inside, and it will give us the very same thing we had there. So now we want our bases to be the same. So now the bases are not the same. So how do we make the bases to be the same? What happens is that if you swap the fractions inside the bracket, the exponent will change the sign. So we can just do that. We're going to say now, okay, we have now 2 over 3 all to the power of x, but now we just swap now what is at the bottom comes at the top, what is at the top comes at the bottom. So this is just going to be 2 over 3. But now if we do that, the sign of the exponent will change. It's just going to be negative 2. And therefore we can see that we have the same basis. So what we do, we drop the basis and we equate the exponent. So that's going to be x is equal negative 2. Thank you very much.